Okay, I think we're ready to go. It looks like it's going. Today we're back in Fusion. We have, what did we do last time? Last time we were, let me check. I don't actually remember exactly what we were doing last time. Oh, we tried the transfer sheets. And one of them, the vinyl one, kind of worked. The inkjet iron-on thing did not work, but I have others. I guess they're not out here. I ordered the transparency film, so the overhead projector film that you can print on with the inkjet. I think it might work. I don't know if it works with the laser. Here it is. Well, it doesn't give you a whole lot of direction on here. It says this side is the printing side. I'm thinking this is inkjet though. Not many people use overhead projectors anymore. But what they found that you can do with this stuff is kind of like for making PCB masks and things like that for printed circuit boards. But apparently this will also hold ink well enough that it will but not so strongly that it won't transfer. So we'll see if this transfers. Again, I don't know if I have to print this in an inkjet. I'm kind of not excited about running this through not an inkjet, a laser printer, because it might melt and gum up everything. So I'll have to check and see if I can do laser on this or just inkjet. I think the laser toner transfer would work better than the inkjet pigment transfer, but we'll see. What else did I get? I have some clear resin. So we have this. I got the Anycubic. I haven't even opened it yet, but it's just clear resin. Now, one thing with the clear resins is that they don't really stay perfectly optically clear. These are UV cure, and a lot of times these will turn yellow on you. So in this case, I'm not too worried, because what we're actually trying to do is print a kind of smoke tint canopy. This is what we got. And I think we can tint this with a little bit of a dark color, whatever I have. Maybe I have a black, I don't know. But an ink tint of sorts. And then if it yellows, maybe it, I don't know, maybe it might turn a little green, I don't know. But we have that. And I picked up some filament because the Prime Day sales were actually pretty good. This is also Anycubic, and it's just a different color. Tropical turquoise. So I picked that up just to print with. I noticed on Amazon, I guess if you print a lot of the same color material, they do have a subscribe and save option that gets the filament down below $10 a kilogram. But you have to do the subscribe, and there might be a minimum you have to do. I don't know. But that was didn't sign up for that because I don't know if I would print the same color that often. But maybe there's some tweaks you could do to it to only have it ship every 3 months or something. I don't know. Depends on how much you print. So I have those. I got a couple of other things coming in the mail. I have these coming in the mail. So let's see here. This kept showing up on my web page on, I think, Facebook. Let's see. I was trying to get it to fill this. I guess that's close enough to fill on the screen. So what it's doing here is these are mostly water-based filaments. So 70% water. So that's unusual. But, and apparently you can ask ChatGPT how that's possible. I don't know. I didn't do that part. But they had some really cool types of filament. Now, their pictures leave a lot to be desired on their spooling. Look at this. It looks all tangled up. So I hope it actually doesn't come that way. Maybe that makes a cooler aesthetic for the web page, but that looks really hard to print because it looks like it's tangled up. But let's see which ones I got. The soap. So one that you can print it, and apparently it is soap. I think I got the fire one that is combustible, so that you can make things that are in like candles. I did not get these. I got some of the fishing ones. Or I think I got this one, the fish bait. So this one is actually made with here it is, fish and shrimp meal, squid powder and worms, and marine safe binder. So that the idea is that you would make fishing lures. So I don't know, we'll see how that works. And then I think I got this one. I assume this one is mostly like a TPU, but with this filament being mostly water, I don't know what it is. It's supposed to be a rubber-like filament. So see how that goes. You don't get to choose colors on these, as far as I could tell. It's just these are the colors, I suppose. Like this blue is the soap color. I don't know. We'll see. I got those. I think they were relatively cheap, but I think like it's $19, but I don't know that that's a whole kilogram. I think that's a half kilogram. So that puts them on the more expensive side, if that's true. That right now I'm not seeing the amount. I guess if I went to the store, it would probably show me that. And they had a lot of others that, here's the soap one. So yeah, $20, but let's see how much that is. Oh, and you got free shipping if you ordered 5 or more. I don't think you had to order 5 of the same things. Now there, the soap is green, so I don't know. All the others I saw, it was that blue color. Yeah, so 0.77 pounds, so that's not even a half a kilogram, I don't think. Or maybe it is. Maybe that's a half kilogram. I can't think. I don't know. Let's see. Let's see what it says here. Yeah, that's essentially a third of a kilogram. So they're really small rolls. So that puts them at the higher end of expensive. But never printed with them before, so I thought I'd give them a try. Also, I'm debating, haven't done this yet, but there are some really good 3D printable models out there now, but these are not free. So this is just an example. There's a whole set of boats and planes and cars and all that kind of stuff on this web page, and these are usually built on an RC chassis, and then same thing with these, but again, not free. But if you're interested in some more sophisticated models, these things they do exist, but they're generally not free. They might, if I can find a good one that's free. Well, I showed you the F1, the Open RC. That one is free, and it is nice. It's not as sophisticated as these. It's pretty basic compared to these models. But if you want something that actually functions and is free and you want to try it out, the Open F1 RC, or Open RC, I think it might be what it is, but it's a F1 style car. It's a relatively easy print. I'm looking at it over there. Relatively easy print. Why don't I get it in case you didn't see it the time that I showed it? Let's see if we can get it on the camera. We got to move the X30. Okay, it's going to take up all the camera though. Let's see. There it is. So it's a relatively large model. It's several pieces, not one giant piece. But you can print everything, even the tires or TPU. It does have a couple of pieces of hardware you have to have, like nuts and bolts. And then if you want it to be a RC, then obviously you got to have the radio control parts. But it can be a static model that doesn't actually do any. Well, I guess it would roll if you pushed it, but it'll assemble with just a couple of screws and nuts. So there were nuts and screws types of assembly, but it's all free. The models for it are all free, and so that's if you're interested in building a bigger thing, but you don't want to pay $50 or whatever for a model. There is the OpenRC on printables is where I got the files for this one, I believe, and there's good assembly instructions and all that kind of stuff for it. And there's a lot of people have modded, you know, put different wings, or they made a little driver for it, all kinds of different things that you could add to it. So that one is actually free. It won't assemble if you don't have some kind of the right size screws to put it together. They're all little metric M3s, I think. And so I can't remember if they make a kit. I think there might be a kit that is put together, maybe in a link on the printable site that goes to the actual designer's site. He might have some little kits you can buy that are all the hardware pieces versus having to sort them yourselves. Anyway, that's all out there. What we're doing today is not that. What we're doing today is we still haven't gotten, we lost a sidewinder, a canopy for this. So I built this first draft. Wait, that's backwards. I think it goes this way. No, it does go the other way. Doesn't quite fit yet, but the first iteration of it, I built something. I think it goes that way. I didn't build the little attachment point, so it's not indexing, and it's a little bit too narrow. Although I think that's the way it. Can't remember which way it's supposed to go, but it roughly fits. But we've got some work to do. So we're gonna build that today. I don't think we'll build this attachment point today. That's something I got to figure out. And there's a little nub that goes in there to lock it in place. I just printed this in black PLA so that it was not wasting resin. It's easier to print this than to get the resin machine up and running. Plus, at the time, the clear resin hadn't come in. Looks like we lost a canard here. All right. So this one, when we first started this, we made these. Well, we made the rear versions of these. We made these, and we just had one, and we took an overhead picture of it, and basically just traced it in Fusion, and then thickened it a little bit, and put a couple of the. I put you can see some of them there. Put some of the panel lines. I didn't put all of them, just to show that you can put the panel lines on there. And so that was relatively straightforward. Then we made this guy. We scanned not all of the jet, but a lot of the body of the jet with a Revopoint POP, the original POP scanner. I think they're on like POP 3 now. But it is a structured light scanner, so it shines a pattern on the object, and it knows like a grid, and that grid gets deformed as it wraps around the object, and the scanner sees the deformation, and then the software can interpret, oh, this must be the geometry that caused that kind of deformation to this grid pattern that I projected onto the surface. So we did that, and we made this piece with Fusion also, and we used the mesh tools and some mesh section analysis, and then we created some lofts. Well, we created some profiles and used those profiles to create a loft and made this little guy. It's pretty much there. It also has a little nub that attaches down in there, and it's a little loose. You know, it doesn't really like lock in there, but for the most part, that fits. Other than it's a different color plastic. This one, I thought we would use the form tools. So they're a little bit more organic, I guess, and we can't really just take an overhead picture and model it. I guess you could try. Since we have this scan geometry, it's not super accurate, but it is there. We'll use that, and we'll use a like a right side view image of this of the real one. Well, not a real one. They did make planes like this. About when this one came out, there were some jets, kind of experimental jets. I think they were the X-29. Let's see if that's right. This is G.I. Joe, and it's called the X-30 Conquest. I think the real one, yeah. Let's see where we at. The real one is the Grumman X-29, and it was experimental. I don't know that it was ever actually produced, but you can definitely see that they are similar. And there's a Soviet one that's really close to the thing that the X30 looks like, but it came out after the G.I. Joe version did. Or, well, you know, when did they start developing it? Who knows? But so there is sort of this kind of plane for real. But I found an X30 box. So I found this on eBay, and on it has a hand-drawn side view. And so I took this little piece, basically, screenshot that piece, and we're going to use that as our profile view, and then the scan data as our, you know, base to get the shape of this opening. So that's what we're going to do. I've already downloaded this picture, and we're over in Fusion. This is what I ended up with. It's not perfect. Got some weirdness in here with the way that the geometry came together, but I just wanted to show you, and apparently I've got some errors. Mesh is not closed. That's fine. That's fine for what we're doing. It's not good though. And we'll see how to get to something like this with a different set of tools that we haven't used before. SolidWorks can probably do a similar thing, but I just haven't used those tools in SolidWorks as much as I have in Fusion. So, and I haven't used them in Fusion a whole lot. So we might stumble around a little bit, and there probably are slightly better ways to do this than what we'll do. But let's start a new one. New design. And the first thing we need to do is we need to bring in our scan geometry. So that's insert mesh. And I have to find it on the computer. So not 100% sure where I put it. I think I put it away. There it is. So this is what we have from the scan, and this is an older scanner, and it's cheap. So, but not like Walmart cheap. It's cheap for a scanner. It was $600 or $700, and when I scanned it, I wasn't paying super great attention to X, Y, and Z, and so the geometry is a little bit twisted. So let's arrange it to where it's more or less oriented in a normal looking view. So it thinks that's the front view, which pretty sure that's not what I want to call the front. So let's try to get more aligned with what front really looks like. Whoops. Let's move it to the ground. That's not far. Let's see if we can get it. It's very finicky here. I'm looking at these markers to see if they're more or less the same. That looks pretty close, so we'll center on that. Let's look at the right side view and see if we're a little bit tilted up, I would say. So let's do more like that. So there's front. Let's look at the top view and see if we're twisted a little bit there. That's probably pretty close, I think. Pretty close. We'll center on that. All right, so one thing with scan geometry is, in general, you don't have to scale it. It should come in with the right dimensions. Now, it could be off. Your scanner set to millimeters and you import it as inches, so it could be off like that, like a conversion factor, but it's usually not off very much on this actual scale. So I don't think we need to scale it. We do have this, I guess this got part of the tabletop. So we're going to go into the mesh tools. So this is just a mesh. Just go over here to the mesh tools, and let's do some direct editing, and we'll select the one mesh that we have to edit, and then let's just cut those out. So we will do a freeform selection and just hit delete. And we could trim off some of these other pieces also, but I think they'll be fine for now. Notice, let's finish that. Notice I've got this big hole over here. What that's from is, remember, these scanners have trouble with detecting really dark objects, transparent objects, and reflective objects, because it's trying to project a grid onto it and then see that grid. and so if the grid can't be seen for whatever reason, it has trouble interpreting it. And that spot is right where this logo was, so it's really dark in there and you just missed most of it. All right, so back to our Fusion. Let's see if we can get it to kind of be on the screen in a reasonable way. That looks mostly good. All right, so we've got our, whoa, you know, see, our geometry here is not perfect, but I think it's close enough that we'll be able to get something. Well, we already got something that's pretty close. You know, we have this one, and it's pretty close, but I did not spend a lot of time, you know, tweaking it, and that was the first print of it that I had. Let's try and bring in our, whoops, not that corner, the right. Let's try and bring in our reference image to get this profile. And for that, again, we're just going to use the image I got from this page. So we need a canvas so to put it on. Well, we need a plane to put that canvas on. So let's show the origin, and let's see where we're at. So we're not quite centered on the origin. Let's go to a direct top view, and let's see where. All right, so there's directly overhead. There's the XZ plane, no, YZ plane, I guess. And it's a little off. It needs to be through the center of this center line. So let's move. Let's go back to our mesh, I guess, and let's move it. And let's just line. Oh, I didn't want to tilt it. I wanted to move it. I think I grabbed the. Or we're still back straight. Yeah, I think we are. All right, let's go back to the top view. All right, move. Let's grab that one. Now, see how you can see the plane there. I need the plane I'm trying to move to. I need that to be like, I need to be right up above it. I don't know how well on your screen you can see. I can barely see on, well, there you can see better if I highlight it. All right, that's relatively close to center. There's probably better ways that we can get that, but now we've got this plane right here more or less centered along our thing. We could spend more time getting everything aligned, but I think we're close enough for what we're going to do. But if you were trying to do an engineering type of thing where you've got some sort of scan of an actual part, you probably need to find more reference points and get everything locked down in a more rigid way than what we did here, just eyeballing it. All right, let's put our insert our canvas. So canvas is, well, even shows the pop-up, shows you kind of how it's being a reference image there. Insert from my computer. I assume I put it on the desktop. No, it's this. Yeah, there it is. All right, so it came in. Now we've got to get it scaled because it's way down here. So still too small. A little big. It doesn't always like to move smoothly. I could probably type in a number. I just don't know the number to type in. Although it's a little bigger than that, I guess. You know, that's probably pretty close. Goes there. It's pretty close. It could be closer. And again, we're not going to make an exact copy, I'm sure. All right, so now we've got our scan data, and we've got a profile that we can reference for what, you know, generally this thing's supposed to look like. So here's where we'll do some new stuff. We've kind of done some of that before. We brought in pictures and we brought in this geometry when we made the mesh back here. Now I can tell that it looks like we're off a little bit on where the where our geometry here. I think that line is actually that line, you know, and they're scaled off a little bit. So we probably are not quite perfectly scaled, and I don't know if this drawing on the back of the box is from any of their engineering drawings or if it's hand drawn, just kind of this is what it kind of looks like. So I don't know how accurate any of that is, but this will give us a general guideline because we're not trying to be perfect here. So instead of doing the loft tool like we did for this little piece back here on the back, we're going to use the form tool. So that's in surface over here, and it's this purple create form. And so the idea with these forms is that you're going to use these T-splines, and so it's sort of like Bezier curves where you've got the control points. It's sort of like that, except now the splines actually are representing a collection of splines will actually represent a surface, and we can deform that surface to match whatever geometry we want. So we're going to go into the form tool. Now there is a cylinder that we could probably drop a cylinder on here directly, and that might be the better way to do this. I have not actually done that before. I'm just going to start with a face. There's also a plane that is similar to a face, but we're just going to start with a single face, and then we will add vertices and lines, edges, not lines, edges to that face, and we will make it match the geometry that we have as good as we can. So I'm going to create a face. I need to create a face, and I want it to be on that plane, not the airplane, but I guess my origin, I can't see it right now. So it's the YZ plane. If I'm looking, oh, it's you can't see it. let me squish. Oh, wrong one. Let me squish this in a little bit so you can kind of see. There we go. Over here, the YZ plane is that plane where we centered everything. So I'm going to choose the YZ plane as where we're going to put this face. And then now I've got this crosshair that I can probably be better to go back to the right side view, and I can draw my first plane. Now a plane here is a it has 4 points, and actually it might make more sense to draw it from the top. So here, and it won't be perfect. Oh, actually I can't draw it from the top because I'm drawing on that plane, aren't I? I'm drawing on the right plane, so I can't draw it from there. So I either need to draw it on the what plane? The XZ plane. Maybe we could do that and draw it from the top. Let's try that. So let's cancel that, and let's look at the top view, and let's try to put a new face in on the XZ plane, and we'll do here. Now I did not really pay attention to where. Oh, I've got them backwards. Whoops. All right. There we go. There, and somewhere in there. All right, so it put it way down here, right? And I want it up in this region, so I need to move that thing around. So now that we're in the form, notice I've got a finish form button over here. I can get some of my real estate back. I've got this finish form button, so whenever I'm done, then I'll go back to the regular modeling tools that I would be using. But as long as I'm working on the form, then I have this new set of tools up here that are specific to edges and vertices and things like that. If for some reason I finish the form and I want to go back, you can go back and edit it. The easiest way is go down to your timeline, which is almost off the screen down there. Let's see if I can go down to your timeline. There's the form that you're working on. Right click. Well, I probably can't do it right now because I am in the edit form, but right click on that and edit it, and it'll take you back to where you can edit this form. So clearly we got to move this thing up, So we will just go to this first edit form button, and we'll just, since we have it selected, we'll just move the whole thing up. Now, I do want to assume that this canopy is symmetric about the YZ plane. So before I do any building out of this thing, I'm going to go ahead and turn on symmetry. So I've got a symmetry button right here. And there's a couple of options here. I want the duplicate mirror is what I want. So I'm going to select, I think it selected it automatically, and the mirror plane will be the YZ plane. And there it just created a mirror of it. Okay, so now anything I do on this side automatically happens on this side. So the first thing I need is, right now I basically have two boxes. I can work with that plane, rectangle, and therefore this one also, because it's just going to be the mirror image of it. So I need more points of control. So what I'm going to do is I'm going to select maybe this line, and I'm going to insert an edge. So right here, there are probably shortcut keys for these. I just don't know what they are, or maybe you can assign them, but I'm going to actually click the buttons. So insert an edge, and you'll see a new edge pop in here, and this by default, the new edge pops in. You can even see in this pop-up little box here, 0.5, it pops in at 50% of the distance between the edge I selected and the next edge it sees, so the one over here. So right in the middle is what it does, which that's probably fine. So we'll leave that, but let's put some more in there. So let's put another insert edge in the middle point there. Let's click OK. How I'm selecting this, I'm just clicking on these and selecting the edge. And we'll insert one there. OK. And it by symmetry added one there. So that gives me some control. I probably need some in this other direction. Now if I click just this, click once, it's only going to put an edge right here, but I want an edge that goes down the whole thing. So I could go and select all of these individually. Well, I don't need the airplane body. You know, hold down control and select them. The easier thing when you're working with a form like this, if you want to select a whole chain of edges, then just double click on one of them and it'll select all of them. It's not a big deal when there's 4 of them, but when you've got a lot of edges in there, then it might start to be a big deal. So insert edge, that'll put one in the middle there, and when I click OK, it'll actually add the matching one on the other side. So now I've got more vertices, all these little intersection points for the edges. I've got more of those now. So now I can start to move these around. Now it is possible that you can actually have these snap down to the mesh, and we could try that. Since my mesh is kind of rough, I don't know how well it'll work, but we'll try it. But first, let's get them in the right position here, because they're not right. Like we need to match. We need to start matching these up. I can't even really see where the thing is there. It looks like it kind of is back there. All right, so I'm going to go to a top view, and I'm going to start moving these to follow this outline. And so that's just modify edit form, and then I can click on a individual button, and it will give me some tools where I can start moving them to where I think they should be. One thing you want to try and maintain is you kind of want your grid here, the dark edges, to not have any of the rectangles that are really skewed, like really thin and long or twisted up. You want them, now I'm going to have some because I've got this corner back here, but you want them to be as much as rectangular as you can. I don't like this is actually a rectangle, but these two edges are almost in line with each other. Not ideal, but that's what we're going with right now. So let's see if we can, same thing up here. In fact, this one in the actual print, you can see how it didn't come out the way you would want. Oh, Get off of there. There we go. It has a little bit of a corner there that you wouldn't really want. Now, I don't have a real canopy that goes on one of these, so I don't know what they actually look like, but I suspect it doesn't have a corner there. Let's see, is this more or less... trying to see what edge I want to follow. I kind of want to follow that edge. Is that the one I don't know, it's relatively close. Somewhat close. Alright, let's go to our right side view. So it's still floating up in the air, and theoretically what we can do is we can take and select these edges, hold down, let's see, that one, hold down Control to select a whole set of them. I don't know how well this will work, but we're going to give it a try. So I've selected these edges, and I do have a button here. Which one is it? Pull, I think. So the pull button here is supposed to snap any of the T-spline vertices. So the lines that I've drawn are the T-splines, and the points that I have selected are the vertices of those T-splines. So I've got a set of them selected, and it should pull them down to a target mesh. And my target mesh will be the body of the plane. So I guess I have to select them now. So it's kind of working. I don't think there's anything for this one to pull down to, so I'm not going to select it. Now these kind of overshot, but that's okay. And already I've got something that, you know, it's not looking terrible, but it did overshoot here, right? So clearly that one went like down through the thing. So let's modify our mesh, or edit our form rather, not our mesh. And let's just pull that one back up. When you're trying to move the vertices around, I do have these little squares that let me move in a plane, and then I have the arrows that let me move in a direction. So in this case, I'm probably just going to use the direction, and I'm watching where does it seem to intersect the scan mesh with. So there it's down in the thing, and there it's kind of on top of it, and so I can go and tweak these until I get them. You know, notice this one does affect that one and so forth. So there is some back and forth you have to deal with. But I mean, that's not horrible already. Got some weird kind of shape going on back there. See how it kind of does a weird convex and concave at the same time shape. Also, if we look at our right side view, we're not quite matching our profile, so it would be nice to probably match the thing. Also, I do have, what I'm looking at here currently is the smooth view, which is what I'll export when I print, but it's often good, I think Alt and 1. This is the base mesh that the smooth one is being built on. So it's also pretty good to make sure that your base mesh doesn't look weird. And here it's more obvious that, you know, I've got a kind of odd set of faces back here. And maybe I can add some lines to get this transition better. And, you know, this guy is probably way off of where it needs to be. So you Alt 1 will go to this version. Alt 2 kind of shows you the both of them at the same time. So you can kind of see how the base cage is affecting the smooth version. And then 3 is just a smooth. 4, I don't think does anything. So 1 and 3 are kind of the ones. You can work in this one too, the Alt 2. The Alt key and the key number 2 on your keyboard. I just find it hard to do. So I go to 1 and get things, you know, organized looking, and then 3 to see what it's going to look like on the print when I print it. So I think what I want to do is let's get it raised up to better match this profile here and see what that does to this weird kind of flare that I've got back here. So let's raise this guy up, and that one. And you can raise, or you can edit more than one at a time. You can select a set of them. I'm just doing one at a time. These two might need to go forward a little bit, I'm thinking. And maybe this one needs to go forward. And I might have to add something to get that little bit more bulge there. Now let's look at the, yeah, look how see, that is no good, right? So let's, and you can't, it's harder to see that in the smooth view. Actually, that made it match the profile pretty close. That's not bad at all. I still have maybe that point might need to roll down. Maybe we need a line, an edge through here to kind of pull this out a little bit, I think. So let's take now, let's see, this is a weird face, right? So that face might be kind of hard to deal with. So I think I need to maybe this one, this one, this one, and that one, and insert an edge. We can always undo if we don't like it. All right, so that might give us some more to work with. Because what I don't like the way that kind of comes concave right there. So let's take that point and pull it out, and then let's see if we can do something with this. All right, so we got to go back to edit form, get those looking better. That looks okay. This part, might need to. All right, let's see what the smooth version of that looks like. So pretty nice. That's a very long, skinny face I don't care for, but doesn't look bad. The only thing now is, looks like it needs to come back to here, so I probably need to try and move that one back and up. Now that probably, let's check the wireframe. That actually is not bad. Alright, so we don't have our little connection point here. We'll worry with that later. Probably off the, that'll be more of our regular modeling that we normally do. So I'm not going to worry with that here. It's looks pretty good. So let's say okay. Now right now it is only a surface. It is infinitely thin. So we can't print infinitely thin. So I do need to thicken it up. So there's literally a command called thicken right here. So we will just select what we want to thicken, this surface, and then the direction. So we want it to go down, and it probably needs to be in the range of 2 millimeters. That's probably a little bit overkill, but probably what we need. Let's do a soft thicken. That's dealing with the corners of it or the edges of it mainly. And then normal, meaning perpendicular normal. We could just go in one direction. Would it be better to just go in the straight down direction? That might be better. I don't know. It's going to be very similar. Let's go with normal. Alright. So now, let's get our thing back on the screen here. Let's hide some of this other stuff so let's hide the mesh, hide the canvas. that's our canopy. I mean, that looks reasonable. It's missing a few details. So if we looked at the actual plane, do I have a picture? Well, see if there's any of these that have. Here's one. Except it won't go to that one. It has a it has a little rib here that we did not model, and we didn't model at all those hinges. So we'll worry with those at some other time. Wow, that picture is doing some. There we go. And it might have a kind of like a frame all the way around it. It's kind of hard to tell, but it looks like maybe there's a frame all the way around. We could go back and add that as well. First, I just want to print the shape and make sure that we've got the shape more or less right and scaled right, and then we'll add these details like this rib and the hinge that actually holds it in place, and the little notch or the tab that will interface with that notch. If we get that right, I'll print it on PLA first, just because that's an easier to print thing. Then we'll get our clear resin, and we'll just print it with the plain clear first, and then we'll see if we can get it to kind of have a smoky tint to it, like this one does, kind of a grayish tint. And then we'll be almost finished with this. We haven't built our front landing gear yet, though, so it has no way, it can't really sit on its landing gear the right way. So we'll have to do that. Most of that, though, may not even be worth doing as part of the class, because it's really just plain modeling. There's not any fancy things that you might not have already done with that. So I might just model those and print them. And then we'll have a much better than what we started with plane here. Still needs cleaning and all that. It's kind of grungy, but it'll work better. So let's see, it's 8:47. I think we actually have time to do our nozzle swap over here. So over here, let's see if we can get down. Now, I've done one of these already in the past on this printer, and what we ended up doing is I thought it had a 0.6 millimeter nozzle, but it actually had a 0.4, and I put a 0.4 on it, so I just swatched out the same thing that we already had. But now I want to put a 0.8 millimeter nozzle in there. So this guy, we're going to put that in there. So the first thing, we need to unload the filament. So to do that, I need to turn it on. I haven't turned it on. And remember, this one's running Clipper, so I can operate it through here once it boots up. But normally I'll run it through a web page to access it. I don't know what IP address it gave it, but once it gets going, I guess it's still booting. All right, now we have the screen here. It's still, you can't see it on your screen, but I can see it. So we could go in here and preheat. We only need the hot end. We don't need the bed to be heated for this. We just need to heat the hot end so that we can take the filament out. It has PLA in there, so we're going to heat to like 200 and pull the filament out. If you don't pull the filament out when you're changing, before you change the nozzle, then you will have more than likely a big mess down here. Why don't we raise this up a little bit? I'm just manually, it hasn't been home, so it's the stepper motors are not locked. I've got a tool to grab the nozzle. I've got a crescent wrench. Actually, this is not Crescent, this is Cobalt brand, but it's an adjustable end wrench so that I can back up the heat block. And I need to get the cover off of here, which I did have a Allen wrench for that, which seems to have gone missing now. Well, where did it go? Let me get another one. Let's see. See this size. Yeah. And you can take this part off beforehand if you want to. You might be able to get in here without removing this shield, but I know you wouldn't be able to see what I was doing if I had the shield on there, so I'm going to take it off of there. I don't know if you'd be able to easily back up any of the heat block, like hold the heat block. I don't know if you'd be able to do that very easily. Now this fan is running, so you kind of have to not get it in the way of anything. All right, this is not, let's see if we can get a little closer to that. This is not the fan, the hot end that you normally have. This is apparently a spider version of a hot end, but it's similar. Now I have heated this up, so you have to be careful here. And again, you could remove this part already before even this. Where's that? Even this is hot, and this is just a piece of silicone. So remember a couple of things to be careful of. One, this is 200. Yeah, I've got it at 200 degrees Celsius, so it's hot. This is your heater, and so these heater wires, they're pretty robust. They're not going to be in much danger of coming loose, but behind them, and you can't really see them, I don't want to pull on them a lot, but yeah, those white wires back there, like those, they're not even really white, they're kind of a translucent, though in this one anyway, they could be different colors, but the thinner wires, they are going to your thermistor. And so what that does is that's what's measuring the temperature. So if something happens to the thermistor, then it comes you break a wire on it, or it comes out of the heat block. If something happens to it and it's not accurately measuring the temperature of the heat block there, then you're gonna have problems heating the heat block. Hopefully, if that happens, then your printer is equipped with thermal runaway protection, which means that it detects that, hey, I'm telling the heater to heat up, nothing's happening, so something's not right. It's not heating up at the rate I expect it to heat up according to my measurements. And so it'll just shut down. If you don't have thermal runaway protection enabled and something's wrong with your thermistor, then it will continue to try and heat up because it's not measuring any temperature change. And so even though you're actually heating it up, it doesn't think you are because the thermistor is not measuring the temperature. And that can lead to some serious problems. So try not to damage your thermistor. All right, so normally I push down a little bit so you can see something come out, and then I just pull it out. That should give you a nice clean end here. And get most of the filament out. There'll still be a little bit stuck in the nozzle itself, but you can't get all of it out. Alright, so I need now, you gotta hold the block somehow. This is kind of in the way. I want to see if I can get it. It has wires attached to it also, so you have to be kind of careful that you don't rip those wires out. I'm gonna let it sit up there. And I want to hold this, and I've got a massive, this is like way overkill. I want it massive because I don't want it to heat up very fast. If you have a little flimsy wrench of some sort and you put it on the heat block that's 200 plus degrees Celsius, it won't take long for that thing to heat up, and then you won't be able to hold the backup wrench. And if you don't hold the backup wrench, then when you go to, same thing here, I want this one to be kind of massive too. When you go to actually untighten this, then it will have a good chance of shearing. All right, so, and you can cool this down now. So we could set the temperature. I'm going to set it over here in Clipper. I'm going to set it back to 0, so it'll go to room temperature. This needs to be heated though when you're undoing this nozzle. If it's not heated when you go to, whoop, there it went. When you go to take that out, then you stand even more chance of breaking, usually shearing. Oh, I'm pointing to stuff you can't see. That's the new one. Here's the replacement one. You stand a good chance of shearing those threads off if you try to remove the nozzle without it being heated. So you could let it cool down now. I don't want that could take 10 minutes or something. So I will just be very careful and put this guy back in here. So this is our 0.8 millimeter, much larger diameter, and I'll just put this guy back in here right now. It is cooling down, but it's still way hotter than what you would want. Okay. Same. Now I'm going to heat back up now. I'm actually going to heat it to 220. So that right there is snug, meaning that I can feel resistance when I'm tightening it. You want to heat the nozzle up and then go another, I don't know, so it was right here. I want to go to maybe over here. So like a quarter turn past snug. And what that'll do is that will make sure that you don't have filament leaks out of the threads of your nozzle. So it's heated up. Again, you want to hold some back up here, and I want to go maybe a quarter-ish turn past snug. There it goes. Well, not even a quarter, it's more like an eighth turn. I just don't want it leaking out, but you have to hold the heat block while it's heated. So we've done all the parts where it's heated. We can go back to cool now, and we need to put this back on, which I'll probably wait till it cools off, and then we need to put this guy back on. And if I kind of set this back in place, it'll at least help cool it a little faster. And then we want to also remember that we need to change our slicer. So in our slicer, which I don't have open right now, we need to tell it that we are going to use a 0.8 millimeter nozzle, which if we do that, that will put in all the default settings for line widths. But now we were at a 0.4 millimeter nozzle. Now if I want to print the same amount of wall material, I can do half as many walls. So if I want to print, I was wanting a part strong, and I was printing like 4 walls on the thing before. I can get the same amount of material in just 2 walls. I probably cannot go very thin. Remember, in general, like the layer thickness, in general you can do 25% up to 75% of your nozzle diameter. So I can't go down to the 0.1 layer thickness very easily. You know, I might get it to print down there, but I'm really aiming at printing big chunky things now. So I probably won't print our little canopy that we just designed. You know, this guy, probably won't print it on here because it's going to have these big layers. I'm expecting to print like 0.6 millimeter layer thickness now. So I probably won't use it for that kind of thing, but for faster and large prints, now that's what we're going to do with this guy. I don't think we have time to actually set up any print and print it, because I really do want it to cool down before I go back to putting all this together, just because I want to be really careful around the thermistor wires and make sure they're working fine. And we can also look in the readouts. So over here on the screen, we want to make sure that the readouts are good for our temperature and they make sense, and then maybe we'll do some test prints, and we'll get back to printing with some new thicker layers. Maybe I don't know how long it's going to take for this new material to come in. Maybe we can use it in here and see how that goes. All right, I will print this guy out so that we can see how it goes. If it works well, I'll add our hinge and our little prong tab up here and print it in the resin so that we can see what it's going to look like on the actual jet. I'll first print it in PLA just like it is, without any of that other stuff, to make sure it's kind of the right size and looks good. And then we'll move into printing it in resin, and then we're almost done with that. Upcoming, we've got some finishing techniques. So like, how do you paint these things? There's a metal casting and there's a vacuum forming coming up. If you have any other topics that you're interested in, let me know. We've got probably, we're on 17, so we've got like 10 to 12 more topics before we are in for the summer. So if there's anything you want to try and fit in there, let me know. All right, I will see y'all Wednesday.